Question 13 asked me to find the indefinite integral. Remember, as we're jumping between these different types of integrals that we did at the end, whenever something's indefinite, doesn't have numbers on it, you're always going to need that plus c. So here as I integrate, this used to be to the 3/2 power. I'm going to add 1 to that power. Really, I'm going to add 2 over 2. So it becomes x to the 5/2 divided by the new power, 5/2. I'm going to add to that, this x is to the first power. It's going to now become 12x to the second power. I divide by the new power 2. For 6, it just adds an x to it, so it becomes 6x. And then again, I always need to remember that plus c when I do indefinite integrals. Cleaning this up slightly, dividing by 5/2 is like multiplying by 2/5, so that 2 goes to the top, the 5 goes to the bottom. Something to the 5/2 power really means the root of x to the 5th. I'm going to add to that, when I reduce 12 divided by 2, it gives me 6x squared. And then I'm going to add 6x and always remember that plus c. I will say that it's probably fine to leave this to the 5/2 power. If they originally gave it to us the 3/2, I'm just really used to going back to roots and powers. When I'm asked to find a particular solution, basically that means they want me to solve for c after integrating the derivative. So we know the derivative of an equation was 8x. If we're going to integrate that, we're going to take 8x dx, and it's going to become 8x to the second over 2 plus c. When I divide that by 2, it becomes 4x squared plus c. Now that we know this is the original equation, it's going to give me another piece of information. Specifically, f of 0 equals 5. So what that's telling me is the y value is 5 when I plug in 0 everywhere I see an x. That means that 5 equals c. So I can actually write the correct final solution with this initial condition as 4x squared plus 5. Be careful, if this hadn't been 0, it wouldn't always be that this number ends up equaling c. If this had told me something like f of 1 equals 5, I'd need to put the 1 in there. I'd get 4 times 1 squared, or 4, subtract, and it would give me c equals 1. So just be a little bit careful. Don't just assume that that ends up being your c. For number 15, it asked me to evaluate a definite integral. When I integrate 8, it's going to become 8x, and then that definite integral means I need to evaluate it from 3 to 7. Instead of having a plus c, what it really means is I plug in the top number first, 8 times 7. Then I subtract from that, plugging in the bottom number, 8 times 3. 8 times 7 is 56, 8 times 3 is 24. When I subtract them, I get 32. For number 16, it asked me to find the area of the region bounded by y equals 8 plus the cube root of x from x equals 0 to 8 down to the y-axis y equals 0. That's exactly what an integral does. It tells you the area between two x values between a curve and the y-axis. So really those two x values that I'm integrating between are 0 and 8. The f of x that I've been given is 8 plus the cube root of x. Instead of writing it as the cube root of x, I'm going to write it as x to the 1/3 dx. Now when I integrate, it gives me 8x. The 8 gets an x by it. The 1/3, I add 1 to the exponent. So really I add 3 over 3. That's how I get x now to the 4 over 3 divided by 4/3, being evaluated from 0 to 8. I'm going to clean it up a little before I evaluate and make it into 8x plus 3 the cube root of x to the 4th over 4, evaluated from 0 to 8. When I put in 8 here, 8 times 8 gives me 64, plus the cube root of x to the 4th. I could do that in either order. The good news is I do know what the cube root of 8 is. The cube root of 8 is 2. So I'm going to do it that way and say the cube root of 8 is 2. If I take 2 to the 4th, 2 to the 4th gives me 16. So this becomes 64 plus 3 times 16 over 4. Minus, when I put 0 in here, I get 0. When I put 0 in here, I get 0. So really, I'm not subtracting anything. 3 times 16 is going to give me 48. 48 divided by 4 is going to give me 12. So eventually I get 64 plus 12, which gives me the correct final answer, 76.